In today's video, I'm going to show you how to connect and configure the RFM95 module with a Raspberry Pi 0 to W to create your own long-range LoRa node. We'll start with the physical connection. The RFM95 communicates via the SPI interface, so we need to be precise with our GPIO pinout. We are connecting 3.3 volts, ground and the critical signal lines, MOSI, MISO, SCK and chip select. Don't forget the interrupt pins 0 and 1, which are essential for the system to handle radio events properly. Now let's go into the Pi via SSH. We are cloning the repository and trying to run it exactly as the README suggests. Of course, things never work on the first try. The system is throwing errors about missing dependencies, so we need to prep the environment. Instead of cluttering the global system, we'll create a Python virtual environment. Once activated, we'll install the missing links. If you are wondering how professionals create electronics without chaos and with maximum collaboration, the answer is Altium Develop. Imagine an environment where you eliminate the problem of manually emailing files to others, such as mechanical engineer for PCB verification, and start working in real time in one cloud. Altium Develop is an advanced professional central hub that integrates the PCB design tool with the broader ecosystem. With it, you can forget about the frustration and delays that come from constantly losing context and having to manually track corrections. Pi LoRa RFM9X for the protocol, spidev for the bus communication, and RPi-GPIO to control the pins. Even with the packages installed, the script still fails with a device not found error. Quick diagnosis. The SPI interface is disabled by default in Raspberry Pi OS. We need to run sudo raspi-config, head into interface options, and enable SPI. With the SPI bus unlocked, everything finally clicks. The module initializes the radio, sets the frequency, and starts transmitting. Thanks for watching, and I will see you in the next project.